In this video, we are going to talk about word problems with linear equations. Okay, so first off, we're going to talk about modeling problems. And a mathematical model is just a mathematical description of some real world system. Okay. What we want to do is to express some real world relationship in mathematical terms. And so that will let us solve, hopefully, the problem and get the answer. So, one part of these word problems is translating something that's written in a natural language, English, right, into sort of a math language. So that takes some practice and work to be able to do that. There are some particular problems that we'll talk about in this section that you may not be familiar with, but the first couple that we'll look at follow this basic type of equation, and so that's useful to know that a lot of these problems it will involve the cost of some quantity, and and a lot of times they'll involve some variable cost and fixed cost, and you'll see when we get into the problem. So variable costs are costs that that can change, right, and increase, whereas fixed cost would be a cost that stays the same. Okay. So then a lot of these problems will involve the total cost, and the formula would be that the total cost is equal to the variable cost plus a fixed cost. Okay, so just keep that in mind as we're working through this problem. All right, so let's take a look at the first example. It says a moving company charges a base fee of $210 for a move plus $45 per hour of time. Okay, so if H represents the number of hours of time and C represents the total charge for the move, find the relationship between C and H. Okay, so just going back to our basic formula, right? That total cost equals variable cost plus fixed cost. Sorry. Okay, so that's our basic formula right here. So going back to the statement of the problem, right, it says C, the variable C, represents the total charge or total cost, right, for the move. So that variable would be the total cost here. So it would be C. All right. And then the fixed cost is typically a fixed dollar amount and pretty easy to find. So it says a moving company charges a base fee of $210, right? So that would be the fixed cost in the sense, right? You say you have to move, and you only have like a one bedroom apartment, so you don't have that much stuff, right, in your apartment. Then it's going to be $210 plus $45 per hour. Well, that would be exactly the same if you had like a four-bedroom house with lots of stuff in it. It's still going to be $210 plus $45 per hour. So this $210 is the fixed cost. That's the same, right? The base fee. So that goes right there. All right, and then next up is the variable cost, and that is this $45 per hour. Like I said, if you have a one bedroom apartment with not a lot of stuff in it that you have to move, well, it's going to not take that long, right, to move all the stuff. If you have a large house or something with a lot of rooms and a lot of furniture in there, well, it's going to take a lot more time than the one bedroom apartment. So that's an example of the variable cost. The more stuff you have to move, the longer it's going to take, and so the more money it's going to cost. Okay. All right, so now going back to our formula here, we just need to figure that out, right? And the variable cost, right? We know it's going to involve 45 but it's not just 45, it's 45 times the number of hours, right? So for instance, if it took 1 hour to move your stuff, it would be 45 bucks, right? If it took 2 hours to move your stuff, it would be 45 times 2, which is 90 bucks. If it took 3 hours, right, it would be 45 times 3, which is 135. All right, so if you think about how that works, right, what you're doing there is taking 45 and multiplying it times the number of hours, right, to find that variable cost, right? And here in the problem, they tell you H represents the number of hours of time, right? So algebraically, that would just be 45H like this, right? In algebra, juxtaposition, the fact that they are next to each other, right? This 45 and the H means that they are being multiplied together, right? And so this would be the formula. 45 times the number of hours plus $210. And you can see this is a linear equation, right? And so then we could do, once we have this formula, then we could do whatever calculations we want with it. In this problem, they don't want you to do any further calculations. All they want you to do is find the relationship, and so by relationship they mean that equation. And so that's it on that problem. Okay, you don't have to solve or anything like that. All right, let's do one more of those. Okay, next problem says you take a package to the local shipping company. They charge a fixed base cost of $6 per package plus an additional 50 cents per pound. If P represents the total number of pounds of your package and C is the total cost of shipping your package, which of these is the correct relationship between P and C? So again, right, this goes back to total cost is equal to the variable cost plus the fixed cost. Okay. So here they tell us about the total cost. It says C is the total cost, right? So that's pretty straightforward, right? For total cost, we would just have C for cost. Next up, the fixed cost is generally the easier one to deal with. All right, and it says they charge a fixed base cost of $6 per package. All right, so it doesn't matter how much your package weighs. It could weigh an ounce. They're still going to charge you $6 plus they're going to charge you for the weight, right? So the fixed cost here is $6. All right, so that'll be 6. All right, and then it says plus an additional 50 cents per pound, right? So a 1 pound package would cost 50 cents. A 2 pound package would cost $1. 3 pounds, $1.50, and so on and so forth. Okay, so that 50 cents is going to be involved in the variable costs, right? That variable cost is going to vary, right, depending on how heavy your package is. So, and then P, the variable P, represents the number of pounds of the package, right? So again, to make that calculation on the cost, if you think about what we were doing, is all we're doing is taking 50 cents, 0.50, and multiplying it times P. Okay. All right. So so that's it on this particular problem. Again, they just want the correct relationship, so they're talking about the equation in this case. All right. Okay. Next up, these problems are slightly different, okay, than those ones about the costs. All right. Here they are going to ask you to find an equation and then solve it as well. Okay. All right. So when you read through these problems, it says find a number such that 6 more than 1/2 the number is 2/3 the number. Okay. So when you read through these problems, the first thing, right, that you should zone in on is what are they asking for? They're going to tell you to find something. They are going to tell you to figure out what something is, right? They're going to or ask you a question. So you need to locate that. A lot of times it's at the very end of the problem. In this case, right, it's at the very beginning. It says find a number. All right. So that's number one. A lot of times you'll see people read this problem and then you'll ask them, okay, so what is it that you're trying to find here? Okay, and they won't be able to answer the question. So and that happens a lot. So don't panic if that's the case with you, right? It's that's the usual thing that happens, right? So the thing is if you find yourself, you've got to ask yourself that question: what is it they are asking me to find? Because otherwise it wouldn't be called a word problem, right? It's a problem, so they're telling you to find something or do something, right? And then scour the problem. Never mind all this other stuff that they tell you at the very beginning. Just focus on what are they asking for. And there's going to be one little part of the problem that tells you, do this, do that, find this, or what is this, what is that, okay? So here it is, find a number. So what I'm going to do is immediately write that down. That's what I'm looking for, a number. Okay. Okay. And then the next thing you're going to do is give that thing that you're trying to find some variable. Okay. I'm just going to call it X. Other times I'll use, it really doesn't matter what variable you call it, but that's just a common one to use, right, in algebra. Okay. So that's what I'm going to do. The next thing is what we will need to do is walk through this statement again more carefully, reading what they say more carefully. And then what we're trying to do is to translate this from an English, something that's written in English, right, to something that's written in math. All right. Okay, so it says find a number such that 6 more than. Okay. So 6 more than, right, something is, so like let's say that I had 4, right? 6 more than 4 would be 10, right? If you think about, okay, how did you get that? What you did was you added 6, right? So to say something is 6 more than, right? In math, you would represent that as a plus 6, okay? Something, right, that we'll have to fill in here, plus 6. Okay, so 6 more than what? 6 more than 1/2, right? The number. All right, so if you remember, right, and one of the very first things we did was we gave a symbol for this number. So 1/2 the number, X is what we are calling the number. So 1/2 the number would be 1/2 times X. Okay, so if they say twice the number, it would be 2 times X, or 3 times the number, right? It would be 3 times X, or 1/3 the number, right? So that basically translates to whatever that number is times that, times X. A lot of times people will say, well, what's the number? And they'll say, well, I don't know what the number is. And they're exactly right, right? At this point, we don't know the number. The thing is, you've got to remember back to the fact that we don't know what the number is, but we have a little symbol that represents the number. And so that's what should go in here. All right, and then it says is, which almost always in these word problems translates to an equal sign. All right, so that would be is equals 2/3 the number. Okay, so 2/3 the number, right? That translates to 2/3 times X, like so. Okay. So that is the translation part. All right, practicing these is what makes you better at this. A lot of people say the same things to me over and over again. They're like, if I can just get to this part, then I'm good. I can solve it from there. But it's getting to this part that's difficult. And that's absolutely true for everybody, right? Because this is a translation, right? just think about trying to translate something from one language to the other, right? You've got to know both those languages pretty well, right? In order to be able to do that. And so really what this is more of a language issue than anything else that makes these word problems kind of difficult. So, all right. So, and you just kind of get, the more practice you can get doing it, the easier this becomes. Okay. All right. So now we've translated this, right, into an equation. And then what we want to do is to solve it. All right. So this equation has fractions in it. So I am going to immediately clear the fractions by multiplying through by the LCD. I have two fractions. This fraction has a 2 as the denominator. This fraction has a 3, right? So the LCD here would just be a 6, right? 6 would be the smallest number that both 2 and 3 go into evenly. All right, once I know the LCD, then I am going to multiply both sides by the LCD. Over here on the left side, I am going to put that in parentheses since I have multiple terms. Over here on the right side, I don't need to do that because I only have one term here. Okay. All right, next up, I am going to start simplifying both sides as much as possible. So I'm going to multiply the 6 times the 1/2 x. So 6 times 1/2 would come out to be a 3, right? Half of 6 is 3. So 6 times 1/2 x would be 3x. 6 times 6 is 36. All right, over on this, I'm multiplying these two fractions. Remember, you can always write this as a fraction. All right, and so I can see I have a common factor between the numerator and the denominator, which is a 3, right? I have a 3 here, and 6 is 3 times 2. So 3 goes into itself one time. 3 goes into 6 2 times, right? So I have 2 times 2 on top over 1 times 1. So that will be 4 over 1, which I can just write as a 4, and then times this x here. All right. All right, so you can see that multiplying both sides by the LCD did its job of clearing out the fractions. And now it's just an easy, one more thing that we have to do here. That both sides are as simple as possible. We want to add and subtract from both sides so that we get every term with an x on one side, every term without an x on the other side. And the easiest way to do that is to subtract 3x from both sides. So 4x's minus 3x's gives me 1x, which I just write as x, and that's it. I am done. So the number that we were looking for is 36. Okay. Okay, so that's our first example, and what I want to do is go ahead and go through some general steps for the word problems. So this is the general process, a good framework for you to think about when you're working through these problems. So step number 1 would be, what are the things the problem is asking you to find? And that is absolutely key, right? You've got to know what you're looking for. Otherwise, how will you know if you get there, right? So that's number 1. Even if you don't read through the problem the whole way, right? They're gonna throw a lot of details at you and whatnot. Don't worry about all that stuff. Hone in on what are they asking me to find. They are asking me to find a number, okay? So in that previous example. All right, sometimes there might be multiple things that they're asking you to find. In this example, there was only one thing. So label that thing with a variable. All of the things that you figured out, hey, that's what they're asking me to find in the previous, then you would label each one of those things with a variable. In the example that we did, right, we determined they were asking us for a number, so we labeled that with the variable x. All right, so step 3 we didn't have to do in this problem. But if they are asking you to find multiple things, right, then what you would do is to express the other things that you're trying to find in terms of one of the variables in there. Okay, that's because up until the next section, these equations should only have one variable in them. Okay, because the techniques, we haven't gone over the techniques for multiple variables yet. Step 4, set up the equation involving the variable. That's the hard part, right? Is doing the little translation. That takes working through the statement of the problem and translating it over into the corresponding statement in math. Next up is solve the equation, right? So work that out. That's stuff that we've covered in previous videos and previous lessons. And step 6 is make sure that you answer the question. Okay. A lot of times, if they're asking for multiple things, then you'll have to go back and figure out and make some extra calculations. Here we didn't have to, right? They were asking us for this number, and that was X, and boom, we found X right here. But they might be asking you for something different. Okay. And so make sure that you go back and answer the question. Again, revisit and say, hey, did I give them what they were asking for? Okay. So those are some general steps that hopefully will help guide you through this process of solving these word problems. Okay, I'm going to skip over these examples, and I'm going to split these out into their own little videos. So what you should do after watching those examples is work through this word problems with linear equations video. Okay, so like I said, I'm going to stop this one here and then split those 3 examples out into their own videos.